Number 9, we want to find the critical points. That means the relative maximum, the relative minimum, and the point of inflection. Now, we know this is an x cubed, so it's coming down, swinging, and doing that. So we're trying to find this relative minimum, relative maximum. That's what we're going to do first. Now, what do we know is true at those points? Well, what is the slope of that point? It's a perfect horizontal line. The tangent line is, isn't it? So it has a slope of 0. Same up here. It'll have a slope of 0. So what we want to do is find what x values are going to make us have a slope of 0. Well, how do you find the slope at those points? You take the derivative. The derivative will tell us the slope of those points. So let's take the derivative. We get 3x squared plus 6x minus 45. That's the equation, tells you slope anywhere on the black line. Well, I want to know, hey, when does that answer come out to be 0? When does that 3x squared plus 6x minus 45 give me an answer of 0? What x can I plug in there to make it give me an answer of 0? So when we're doing this to find critical points, we take the derivative and set it equal to 0. That's the first step. That's going to help us find the maximum, and relative minimum. Now, this looks complicated, but notice if 3 factors out. That probably is going to make life a lot easier. 3 times what? 15. Now, technically, you could divide by 3 and it'd get rid of it. So really, the 3 is not in play here. We're concentrating on the x squared, silly me, x squared plus 2x minus 15. So what multiplies together gives you 15, but has a difference of 2? Well, that looks like to me it's going to be a plus 5 minus 3. Because you get 5x minus 3x, that gives you the positive 2x, and positive 5 times negative 3 is negative 15. Okay, I'm not going to give you a problem where you got to use a quadratic formula. I'm going to make it factorable. So there we have it. So I'm going to set each piece equal to 0. So either this x plus 5 piece, that thing is going to be a 0, or that is. So either x plus 5 is 0, or my other option is, what about that guy being 0? Subtract 5, you're going to get negative 5 is one possibility. Add 3 to both sides. 3 is your other possibility. So one of these occurs. Now, since you and I know that it looks like this, where's the negative 5? Where's the 3? Well, this would be the x value of negative 5, and here would be 3, because you and I know a number line, negative 5 is first, and then 3 is next, further to the right. That's how come I know that's there. Now, again, we want to I didn't even ask you to, I just said put them as ordered pairs. I don't need to know who's the relative minimum, who's the relative maximum. I just want the ordered pairs. So how am I going to get the y value? Now, notice those points are on the black line, the original black line, right? Now, the original black line was that equation there. So all I got to do is plug negative 5 into this equation and 3 into this equation, and that will tell me where the height is, the y value. So that's what we need to do. So we need to plug negative 5 in and 3 into that original equation. Let's come down here and write the original equation. The original equation was x cubed plus 3x squared minus 45x minus 45x. Okay, so I just want to plug in negative 5 into that and 3 into that. So I want to figure out f of negative 5. That'll tell me the height on the original equation, and then I'll plug in 3. So negative 5 cubed plus 3 times negative 5 squared. Yeah, you might want to grab Mr. Calculator there. Let's see, 125 negative 25, 75, and 45 times that's 225, and it's going to be a positive 225. So here we have negative 50, 225. So I got 175 is what I have there. So that means one of our special ordered pairs, when x is negative 5, the height, the y value is 175. That's one of our critical points. we now need the other critical point where I plug in 3. So f of the original equation of 3. I'm plugging these values I found into the original equation to find what y value goes with them. So 3 cubed plus 3 times 3 squared minus 45 times 3. So we have what? 27 plus 27 minus 135. Okay. For some reason, that seems a bit odd to me, 27 plus 27, but that looks correct. I don't see anything wrong with it. So what do we have here? 54 minus 135. What is that going to give us? Again, you have a calculator. Negative 81. Difference of 81 there. So 3 negative 81 is another critical point. Now, obviously, you can see this is at a height of 175, height of negative 81. You can see this is your minimum, and this is your maximum, but we already said that up above. Okay, so those are our points. Now, how do we find our point of inflection? Point of inflection, okay, point of inflection. Now, what is a point of inflection? That's where when it's bending, it starts bending the other way. It's curving one way, and then it starts bending back. So it's sort of, you're bending in, and then you're starting to change your position. So it's like right in there. Okay, how do we find it? Do the same thing, but we find the second derivative, the derivative of the derivative, second derivative. Now our original derivative is right here. This was, and I should have marked it up here. There we are. 3x squared plus 6x minus 45 is our original. So when we take the derivative of this, it's going to be 6x plus 6. So the second derivative of the derivative, 6x plus 6. You can see this takes a little bit of work. Now, the nice thing is this is pretty easy to set equal to 0. You solve it, you're going to get negative 1. You do have to come back to this original equation, okay, to the original equation here and plug 1 in there. Okay, so we're going to have to plug 1 into that. Now, luckily, that's going to be easier. Problem is I can't ever remember the equation. The original equation, the original equation is x cubed plus 3x squared minus 45x. We're almost done. So f of negative 1. Negative 1 cubed, don't forget your parentheses. 3 times negative 1 squared minus 45 times negative 1. So this is negative 1. This is 3. 45. Looks like our y value will be 47. So we will have a point of inflection at negative 1, the x value, the height will be 47. There's our final critical point.